Guys, in this video I'm going to show you an example of how to calculate strain and elongation of a material due to deformation. So in this example I'm going to calculate for this square 0.15 meters by 0.15 meters. So I'm going to calculate the elongation along AC, right? So what I'm going to do now, firstly I'm going to calculate the resultant length due to this deformation, right? So it goes like this. Initially I've got something like 0.15, so resultant length right, so it will be along this horizontal line, it will be 0.15 and 0.002 meters. So by adding I've got 0.152 meters, right? So this is the final length due to deformation in the horizontal line, right? So I'm going to draw this diagram with the resultant length with all the deformations added on it. So it will be like this. I've got this one, it's elongated to this point, right? And it goes like this, right? So the final length here will be 0.152, right, from here to here, and then from here to here it remains the same. There's no deformation along this vertical line, so it will be 0.15 meters, right, like this. And then I proceed. So from this diagram you can see that this is the x-axis, right? So I will draw a line like this one to show the x-axis, and then the y-axis are going to like this one. This is the y, and don't forget to label your diagram so that you won't go wrong. So this is A and this is B, this is also a D, and this is C, right? So what I'm going to do now, I'm going to calculate the final length of this line AC, right, and also the initial length of this line AC. So you can see that this is a right angled triangle, right, like ABC, right? It's a right angled triangle, so I'm going to use that Pythagoras theorem to calculate the length AC. So AC will be equal to, from Pythagoras theorem, I'm going to add 0.15 squared and another 0.15 squared, because this is squared. So by calculation here I'll get something like 0.212132034 meters, right? So this is the length AC before deflection, right? So now I'm going to calculate AC bar. So what is AC bar? That is the final length here now. So let me say this is C bar and then this is D bar, right? So after deformation, these are the dimensions, right? So I'm going to calculate AC after the material has been deformed. So it will be like this, like Pythagoras theorem again, because this is a right angled triangle. So there is only a change in this line here, this horizontal line. There's this change in meters from 0.15 to 0.152. So I'm going to calculate it like this: 0.15 squared and 0.152 squared. So if I'm going to punch this in a calculator, I'll get something like 0.213555093 meters, right? So this is the final length after deformation. So Now I'm going to calculate elongation. How much did this material go within this line AC, right? So what I'm going to do now, elongation E along AC is calculated by, you will calculate it like final length minus initial length over the initial length, right? So it will be AC bar minus AC all over AC, right? So now I'm going to substitute. I'm going to just punch in from my calculator, and then now I'm going to just substitute the figures, right? So it will be AC bar, this is AC bar, so it's 0.213555093, and then I'll subtract that one, 0.212132034, right? And then I'll divide the whole of it by AC. So this is AC, right? 0.212132034. If I punch these figures in my calculator, I'll get a figure like this. It is 0.00669 meters. So this is the change in the line AC. So thank you guys for watching this video. Don't forget to subscribe to my channel, and I would like to see your comments. If this video was good to you, give it a thumbs up. Thank you. See you next time, guys. Bye bye.